today, I would like to continue with the review of OOP. I think I might need today and plus Thursday to finish everything. But we're going to make sure we get in sync with the other section as well. So today, it's going to be all about reference aliasing and array, some tracing. But before that, let's do some simple topics just to finish off. All right, so let me remind you just a few things, okay? Your Lab 0 Part 2 has been released. It will be due this Friday at 12 noon, the same time for the deadline. And your Lab number 1 is going to be released right after Lab 0 Part 2 is due, maybe about 1 p.m. or so. I'll release it right after so you can get a head start. Lab number 1 is going to be of a completely different format as Lab 0 Part 1 and Part 2, but it's going to reassemble what's going to happen for your programming tests for sure. So make sure you start in time and do your best on that. Your priority now, before Friday, of course, finish Lab 0 Part 2, tutorial videos and also PDFs, right? And especially for the second PDFs, it's really about a programming pattern. For example, if you got a primitive array, products array, let's say PS, and then you got some associated integer counter I, or I can say number of products. That's a naming convention I used in the tutorial. So these two things work together very closely. You want to make sure, number 1, you follow through the tutorial videos. Number 2, read through the PDF as well. All right? So you want to make sure you really get an idea. If you need trouble, if you have trouble reading them, understanding them, please reach out to me. Right? I'm going to leave that part to you. And unfortunately, for this Thursday, office hour 3 p.m., it will have to be rescheduled because I got some conflict. But instead, I'm going to move this 1 hour maybe to Friday afternoon over Zoom. So if you want to talk to me more urgently, so please do it today, 3 p.m. office hour, or I will be attending both lab sessions tomorrow, Wednesday. So you can also speak to me. But for Thursday, sorry, I will not be available during that time. But I'll let you know when exactly on Friday we're going to have the Zoom office hour, most likely in the afternoon, most likely. Before we talk about the stuff today, let's now do some very quick recap about what we spoke about last Thursday. So we started building this little example there for person, and we talk about many useful things. And the first one is we have some customized constructor versus default constructor. Make sure you know the difference. And also, we talk about how you can create new objects using a new keyword. And of course, you can choose to use the way in a memory in the computer to trace it. The value of that is you can know very explicitly about addresses being stored in the reference variable as opposed to some simple values. So that's something you want to make sure you understand. And we talk about variable shadowing. Make sure you know what that really means. And to really get through the variable shadowing, especially when you have the parameter name clashing with the attribute name, you have to use this dot to really disambiguate, we said. Right? That's something we also spoke about in detail. Make sure you also understand that. And we talk about visualizing objects. We're going to need this very badly today once we get to tracing in the exercise. And this will be what I consider maybe the simplest way and the most logical way of doing it. If you really have your own way, be my guest. But you got to make sure you can really trace the code line by line properly. Otherwise, you can easily come up with the wrong answer. Right? That's something we'll see today. And we talk about the 3 different parts when you try to create a new objects. And we try to trace the code, accessor interleaving with the mutators, right? And we talk about things like if you compare 4 lines of code, they look very similar, but somehow they'll give you different results for different reasons, right? You want to review that as well. That's basically what we talk about, right? Do you guys have any questions from last time you would like me to clarify first before we move on to the new subjects? Anything you want me to say? Okay, but if you haven't caught up with the study, you should really do it. Your written test number 1, according to the calendar, is happening in about 2 weeks' time. I will get in touch by giving you some guidance and some example questions, at least 1 week in advance, as I said. Right? But I think maybe I'll give you the guidance for programming test number 1 even earlier, so you can also get prepared for that. Yep, you can just wait for my communication. All right, if you have no question, let's move on. I would like to start with something light. 2 things. Number 1, I want to talk about accessors versus mutators, and then I will talk about how you can design method parameters in general. Very light topics, so that's something you can keep in mind. Also apply into your labs. We talk about accessors, which will be some method that returns something, not void. That's an accessor. And mutator is basically a method that returns void. That's how you tell the difference between the two. And in Java, you will have to be very careful when you are using them. If you're using them in a way that's wrong, you're going to get errors in your projects, in which case you will definitely get penalty for your programming test. Right? Let's take a look. Let's not make the assumption that set weights is a mutator, which will set the weights to be the parameter. Right? The actual coding, we don't need to worry. We're just talking about how you can call the method. Get BMI, we spoke about it last time. It's just going to do some computation and return the double value. Right? Let's go one by one. Consider this line over here. All right? This line here, we are basically doing the following. We want to print out something. Whatever that we want to print out over here is supposed to be a value. Is this line here going to compile or not? Yes or no? Anybody? If you say yes or no, you want to give me some reason for that. Anyone want to try? Should I point to somebody or give it a try? Yeah, go ahead. You won't compile. Why not?
Because set weight does not return type.
Yeah, set weight is actually a mutator. It doesn't return anything for you to actually make use of. Yes, that's right. So what you should really look at is you can see the set weight over here corresponding to return type void, right? So there's no return value. If you try to do this, it's going to give you an error. It's not going to compile, all right? In a very similar way, if you try to also make this mutator call over here, and if you're trying to assign this void value to something else, it's also going to give you an error. You can assign something that's void into something, right? So this is also error. The only legitimate way for you to use a mutator is just by calling it in isolation, something like this. So I'm giving a context object here, and then call the mutator, give the correct parameters or arguments, and then that'll be the right way to do it. So that's why this will be fine. Yes?
Is it okay to think of mutator as like it's a way to change like the memory or
Yeah, maybe I wouldn't think about changing the memory. That might be a little bit too low level, even though you're right. Think about every time you're calling a mutator on some context objects, you're modifying the contents of the context objects. Of course, the object itself is stored in the memory, you're modifying the memory. But you don't want to think about memory at this point. That might be too low level.
And if we want to return the value that was in the mutator, we have to initialize it with a different variable.
Sorry, say it again.
Say we wanted to return the value of the mutator.
You cannot return any value from a mutator.
Can't return it, but
What? Yeah, so what you should do instead, for example, let's say this. Let's say if you really want to somehow return the weights that has been updated by the set weights. Sorry. What you can do instead, maybe before that, you can say print out gym.getWeights. And then that will be an accessor. And after this, you can say again gym.getWeights, which will give you the updated weights. You can never expect any value to be returned from the mutator. That's the main lesson here. Okay? All right. And now, let's now take a look at some accessor method call. Okay? The first one over here, let me look at this one the last, right? Let's ignore that just for now. Okay? The first one. We're still trying to print out something over here. And we are printing out this particular value here. Is that okay? Looks okay, right? Because gym.getBMI, according to the API, is returning a double. So we can definitely print out the double. So this is exactly one of the ways you're supposed to use an accessor. All right? All right, so this one is definitely okay. In a very similar way, you can also assign whatever that's returned from the accessor as a value and assign that to something else. In this case, I'm just assigning that to a double variable. So that's also fine. The last one here is slightly trickier. What I'm doing here is I'm calling the accessor as if it was a mutator, just calling that by isolation. So there are two questions over here. Number one, does this code compile? Number two, is it doing something useful? Okay. Question number one, does it compile? You will think that yes, it does. Okay, yeah, I can tell you it does. You can feel free to try. This one compiles, right? It's important to note. There's nothing that will stop you from calling the accessor just by itself. So this one here compiles, all right? However, is it useful though? You're basically saying, okay, go ahead, calculate the BMI for me. But whatever you calculate, I don't care. Right? I'm not really printing it out. I'm also not assigning that to a variable. So you're not really doing something useful. So what I would say is, but leaving out the return value is not useful. It compiles, but it's not doing something useful. So you want to avoid doing this kind of method call in your labs, right? You don't want to do that. All right, any question about the first topic over here? Just about how you're supposed to make use of the accessor, mutator, right? Make sure you don't really create any errors in your Eclipse project. Question?
What happens to that value?
Good question. You can think about it this way. Somewhere, the question was, if this call over here doesn't really make use of the return value, where does it go? Okay. Somewhere in this getBMI method being called, it's going to say return here. Somewhere here, it's going to say return something. Something. That thing over there is basically like a local variable, only local to this particular method. If that value is not really stored somewhere in the variable or printed out, it just disappears. It will be somehow discarded from the memory, so you don't need to worry. Yeah, there were many things. For those of you who might have programmed in C++ or C before, you might be wondering, do I need to do any memory management? For example, before I create the object, should I allocate the memory for the objects? After using the object, should I deallocate the memory? In Java, fortunately, you don't have to. They don't allow you to do so. There is something called automatic garbage collection. It's a very special term. Oh, sorry. I'm not even spelling that right. Garbage collection. Or this is just another term for automated memory management. Memory management. You don't have to worry about allocating or deallocating memory. Java will just do that for you. Okay. Yes? Yes, of course. The question was, can you add parameters to accessor? That will be more subject to the next page, but I'll just mention that. You can feel free to add parameters to either accessor or mutator, or maybe none of them will take any parameters. It depends on what you really need. For your subsequent labs and the programming tests, all the required methods will indicate how many parameters you will need. So in that way, you have to just follow. On the other hand, if you create any helper methods to really improve the structure of your code, in that way you can design your own methods with any parameter you like. Yeah.
For the purpose of this course, does a mutator have to return void?
No. It's not just for the purpose of this course. It's a rule of the language. You cannot return anything for a void method. Under no circumstances can you return anything for a void method.
Right, but so if a function were to say have set weight, and it would return the previous weight. Would that be considered a mutator?
Well, I think let's not get to the specific. It's easy here, the distinction. Look at the return type for this particular method. If that's void, it's a mutator. Doesn't matter what you call that. Look at the method here, the return type, it's not void. It's an accessor. Also doesn't matter how you call that. I can call this method here set BMI. Nothing wrong with it, but it just returned a double, so it's an accessor. So the way we judge whether it's an accessor or mutator is by looking at the return type. All right? Yes?
What would you call a function that's both an accessor and mutator?
It's, I would say, the way I call it is a bad practice.
Okay.
But I can tell you why, okay? You can do it, but I would highly discourage you not to do it, okay? But let me just tell you, I'm glad you asked the question there. The only way you can have an accessor, okay, let me put it this way. An accessor that is also a mutator. This is the only possibility you can have. Another one for you as an exercise. You're here. Okay, good. Second one, I'll let you think about as an exercise. I'll explain the first one. Okay? A mutator that is an accessor is not possible. Okay, you guys can think about 2 for why. Exercise for you. But for number 1, how can we define an accessor that's also mutator? Okay? You can say, for example, I can say double get BMI. And you can see that it is returning something that's not void. That implies it is an accessor. And of course, at some point, we should return the calculated BMI. Let's say we do that. Right? But now we can also do something that has to do with mutator, meaning that we may modify the object attribute value. We can do that too. Right? So here we might say, for whatever reason, we can say maybe the weights, let me say this dot weights, you will see that's an attributes. Maybe plus equal, I'm just making it up, 23. Okay? You can see this is modification to attributes. Modification to some attribute value, which is weights. You can see this line over here is corresponding to a mutator. And accessor can be seen from this double type over here. So you're really having both. Very bad practice. So I would say try to avoid. Even though once you get more comfortable with your programming skills, you might tend to mix them for convenience. But I would say that could be confusing in a long term. Please try to avoid. That would be my advice. Follow up? Yes, and I'll get to you.
For mutators, are they always void or type void?
They should be void, but at the same time, mutator, the spirit for that is to really modify the attributes for the objects. Of course, you cannot have the method that's void and not void at the same time. So here I'm saying that just by telling the return type over here is an accessor, because you can see double here. Just by telling its return type, return type, it's an accessor. But its spirits also includes to modify the attribute value at the same time. So you're mixing both. That's my point. Yeah.
Why is this dot weight considered a mutator? I thought it identified between attributes and constructors. Or I thought that if you had 2 of the same variable, it identified the attribute.
The reason that I will call this a mutator is because here you can see this a single line over here is trying to modify the attribute value. That's why I call it a mutator. There are 2 ways you can tell. How about that? Either if you just see void over here, it's definitely a mutator. Or if you see the method is trying to modify some attribute value of your class, that's also mutator. You can tell either way. Accessor is when you have some return value over here, so that's why you got to return, right?
So this does modify
It does modify. So that's why I said this is one example where you got accessor mutator field in both, which is not a good practice, right? Try not to mix them. It can seem confusing, right? You're returning something at the same time you're modifying something. You don't want to.
I just don't understand why this is considered mutator. Like I understand
It's by spirit, because you're modifying the attributes.
it modifies.
Well, this weight over here is an attribute, right? Because you're modifying this attribute here is a mutator. Mutator means you're trying to modify some attributes. Mutator here, that means you're trying to modify some attributes. Some attributes. Good? All right, any more questions about this? Nope, just come up with questions. That's okay. All right, the next one on the slides, I would like to just talk about, this slide we already covered. Let's talk about method parameter. This page here is very, just a general principle just about how you can design your own methods with however many parameters you may like. Okay, I'll just go over the principle with you. It's not really meant to be a very complete set of principles, but I can cover some scenario. Okay. All right, so for constructor, typically your constructor should be used to initialize certain attributes. Okay? Hello, please. Thank you. So here, constructor is really meant to initialize the attributes. So for example, let's say this constructor here, we really meant to initialize the weights and heights. And for this constructor over here, we really meant to initialize the first name and last name. So that's why you may have different parameters. So one design principle could be, however many attributes you want to initialize by your constructor, put them as parameters. Okay, that's principle number one. Okay. And what about mutator? Mutator usually you want to modify attributes, right? That's the spirits of the mutator. So basically think about which attribute value you want to modify. And here, for example, let's say I want to move up the points, right? If you have a point over here, you want to move it up, you want to modify its y value to be y prime, right? So that's why I'm providing this particular gap to be modified, right? So that's the unit I'm specifying. Just one example. So for mutator, think about what extra information you will need in order for me to modify the attributes. Again, in the labs, most of the methods will be already fixed for you about what their parameters should be. You don't really have that much freedom. In some way, that's a good thing because you just stick to what's really given to you. But if you want to go beyond what's really given to you, if you want to define some extra additional methods just as helpers, you can definitely try these principles as well. If you run into struggle about, which design should I really go to, come speak to me. I can give you some comments. The final one addresses about accessor, which is actually going to do some computation based on the attribute values usually. Think about, in addition to the attributes I have in the class, is there any additional information I would need for the calculation? For example, when we calculate the BMI, let's say, for example, if I say Jim get BMI, right? In this case, we don't really need any extra parameters because in order to calculate BMI, we need the weights and the heights. Both of them are already available on Jim, the context object. We don't need to pass any extra information. All right, that's empty. On the other hand, for example, let's say in a point class, I want to get some distance from another point. Now you want to tell me what the other point is. There's no way for me to figure out unless you tell me, right? It's the input. Right, so these are the three general principles. Of course, the example here are just for examples, right? There are many other possibilities there. You want to really be a little bit more brave to define your own helper methods in your labs. You got 5 chances, right? You got 5 labs, and try to see a different possibility yourself. And then ask me for feedback. That'll be the best chance to learn. Any questions about this? We're good? All right. Right, so these are pretty light. I think that might be a nice warm-up for today. What we need to really focus on today is about reference aliasing. If you go back to the slides, we also have covered these already. And reference aliasing, that's what we're going to do. And we'll start from scratch. The way reference variable work is very similar to how primitive variable work. So let's now have some corresponding examples side by side to really see how things should be analyzed. And now, starting from now, code tracing is a very critical part to understand the example. Okay? Let's now take a look. I'll switch to here right away. Let's start with something simple here. So this example here is primitive. This example over here is reference. Okay? Don't worry about this one just yet. Let's take a look at this one. We got 3 primitive values over here. Let's just trace them very easily. Line number 1, I3. So we got some box over here, I3. J is assigned to I. What does that mean? We initialize a variable called J, and then we're going to copy the value in I into J. So whatever value is in I, copy that into J. We got 3 here. Easy. And we got another one here. K is assigned to 3. So K here is assigned to 3. So after all these lines, we actually got I, J, and K storing 3 in each, the same value. Okay? And of course, you can do some simple comparison. I equals J. You're comparing whether 3 here is the same as 3 here. They are. So it will be true. And then, what about here? K equals I. K equals I. 3 equals 3. Yeah, that's true. Similarly, K and J, 3 and 3, also true. And you know what this is, right? From first year, conjunction, right? So it's true and true, which is going to give you true. Very simple. I just want to show you, the main line to show you is for this line here. Whenever you want to copy the value of one variable into another, that's how you should think of it. And when you get to the reference type, things will go in a very similar way. But you got to watch out the difference. All right? Let's now look at this one here. Right? That's going to be important. Let's assume we already got a point class which got 2 attributes, x and y. Right? The same as before. How do we trace that? Line number 1. P1 pointing to a new point. Right? We already talked about how you can trace the visualize the object last time. Right? You should really start applying. And we got x and y, 2 and 3. X and y, 2 and 3. That's for this line. Everybody okay with this? And line number 2, this is crucial. What I will do is I'm going to highlight it over here. How do we understand this line over here in orange? What are we doing here? If you compare this line here with this line over here, they work in a very similar way. Here, you're copying whatever that's stored in I and place that into J. Here, we are trying to copy whatever that's in P1, which is no longer any primitive value like a 23. It is some address. Store this address, put this address that is stored in P1 and put it into P2. What does that really mean? Go ahead. Yeah, the same object that P1 is pointing to. How about that? That's exactly right. All right? So guys, there are 2 ways for you to think about this. I'll put it down here. I'll put a star here. Approach number 1, you can think about copy the address that is stored in P1 into P2. But that one is still thinking about like a memory address, right? It's not as ideal. It's not efficient. Number two is something I would like you to get used to. If I say P1 is storing the address of this particular object, now I'm storing this address here to P2. That really is saying P2 should now also be pointing to wherever P1 is pointing to. That's basically what I'm saying. Right? So number two, let P2 point to where P1 points to. The number two over here is very, very crucial for tracing later. Any question so far about?
So does primitive also store addresses?
Sorry?
Does the primitive method also store addresses?
No, primitive variable does not store address. Only reference variable.
What in the code is making it so the reference part is storing address?
Yes, because you see over here, because we declare P2 as a point, it's a reference type. So P2 is going to store an address, right? That's why. So really want to watch out the type over here, int versus point.
So integer.
That's why I put it side by side, right? Are we good about this one here? Guys, I would say this is the most crucial line to understand first. Otherwise, you'll just get lost for all the subsequent tracing. If you really don't quite get this one, don't be shy. Let me know. I can explain again. I don't mind. Yes? Again? Want me to explain again, or you got other question? Go ahead.
If I'm going to pass an object into a method as a argument, does it pass the method make a copy of that variable?
Okay, good. The question was, if I want to pass an object reference into a method as the arguments, what's going to happen? I would say, let's save this topic for after the reading week. It is something called call by value, which I will talk about in detail. So let's not get distracted for now, if you don't mind. It's a good question, but let me answer that after reading week. Okay. Yes? No, P2 holds the, okay, so let's be very careful about the terminology. I'm just trying to correct you guys so you can be as precise as possible. P1 stores an address. P2 stores an address. And now P1 and P2 store the same address. So diagrammatically, they point to the same objects. That would be the correct way to put it. Yes, go ahead. You've got more question. Yes. So the consequence of this would be, for example, good. So let's say this. I can insert a new line over here. Let's say this, right? Right here. Okay, star. All right. So right after I assign P1 to P2, all right? So star. If I say P1 dot, let's say set X, let's say to be 5. Easily, I change this to 5. Now, afterwards, if I say P2 dot get X, is it going to give me 2? Or is it going to give me 5 or something else? 5. According to the diagram, it should be 5, right? This one should give you 5. You can see the interesting phenomenon here about aliasing. I was trying to change the object P1. However, P2 is affected to be 5. That's exactly what reference aliasing is about. Because starting from this point over here, because of this assignment here, P1 and P2 point to the same objects. So whenever you want to change the objects over here, using either of the variable, it's got to be visible to all other variables. That's reference aliasing. Make sense to you? Yeah. All right. And let's now do one more line. This one here. All right, we basically just got another object, P3. Pointing to just another new object here, point. x and y, and then we got 2 and 3. So now we can answer the questions as follows, right? Oh, by the way, after this one here, P2 equals P1, right? We got this. What's going to happen when we say P1 equals P2? True, right? They refer to the same objects, the same address. And let's say after we now got P1, P2, and P3. Let's say we got these 3 objects. Let's answer some questions. P3 equals P1, true or false? False, right? You can see the diagram. Yeah. So P1 pointing to this object, P3 pointing to this object, different. Should be false, right? So this one should be false. What about P3 equals P2? Also false, right? Okay. And false or false? False, all right? If you have some doubts about logical operators, I would suggest you review them. We might have to use them when we get to exception handling a little bit later, okay? All right, so the remaining 2 over here, I'll leave them for exercise to you. You can find the answer from the slides. Basically, just go into, for example, P3.x. P3.x is this, compare the different values, right? You can figure out the answer. But the most important line for you to really understand is this variable assignment, especially when we talk about variable assignment for reference variable. It's going to impact everything that we're going to do later today. All right, any question about this? Everything's good? All right, let's make it harder. Yeah, oh, before that, question. Say it again, sorry, I don't quite catch you.
Why is it necessary to create P2 when I have P1? If I want to make any changes, I will just directly.
Yeah, you can think about it this way. Of course, this example could be a little bit artificial, a little bit contrived. I'm just illustrating to you the points. Typically, if you already got, let's say, P2, let's say, the question was, if we already got P1, why do we need to have another variable pointing to the same object? That's the question, good. The one answer would be for space efficiency. If I already got P1 over here, let's say I want to just somehow create a duplicate of this object here. I got 2 choices, well, more than 1 choice at least. Choice number 1, I can just create a standalone object and let it be P2, different object. That's option number 1, which can take more space, but that's okay, it might be what you need. The most space-saving way to do it would be, let's just create a new address here and let it point to the same objects. In that way, you're only wasting the space of a single reference variable, which is pretty small. Which way you will actually go, really up to how you design your software. I think that once we get to, after the reading week, we're going to talk about aggregation versus composition. You will see a little bit more deeper knowledge about this to see how you can copy the objects. Yeah. Yeah. Yes?
For the primitive example, for object, I,
Variable I wouldn't say object I. Yeah, let's be a little bit precise. Go ahead. Yeah, variable I, yes.
So if you were to change the value of it, would J still equal that one?
Okay, I see what you mean. So here, we got I, J, and K. You're okay with that, right? Okay, let's say this. Here, when I say hypothetically, if I say J over here is simply equal to 4. Oh, you know what? Let me say this. Let me add a new line. Let me add a 4th line here. I might say J is equal to, let's say, 4. The question is it going to impact both I and J, right? Because we did have J is assigned to I before, right? So now let's trace it. J is assigned to 4. J is this box. Change it to be 4. So you don't really impact the other box, I or K. So they are not impacted.
I was saying for I, if you change I, where
Similar. So let's say if you try to change I value, maybe from 3 to 6, for example, you also don't modify J or K at the same time. You don't. They're separate. Yeah, for the reference, here you're using either P1 or P2 as a context object to call the method. For example, let's say setX. Right? So now using P1.setX, would be effectively the same as p2.setX because you're modifying the same objects. Different. I'm glad you asked. All right. All right. Ask me more as we trace more code, right? All right, let's now move on. What I want to do now is to prepare you for that reference aliasing example I would like to do today. But for now, let's just do something as a warm-up, just for you to get more used to array notation. Let's take a look. All right, this one we already talked about. Let's say this one here. I want you to consider these. Okay, let's just trace directly. That might be easier. Okay. Let's trace together. Let's now do these 3 lines, I1, I2, I3. So 3 boxes, I1, I2, and also I3. 1, 2, 3. 1, 2, 3. 1, 2, and 3. That's easy. All right? Let's now see how you can visualize the array. So there are 2 ways you can create the array in Java. One way is you can say declare the array and say that is assigned to, you explicitly enumerate every element in the array. So this will be at index 0, index 1, and index 2. So this will be in index 0, index 1, and index 2. That's one way. Another way to do it would be, you can say, I want to create a new object of the array as if it's like objects, which makes sense. Array is like a reference type. I want to create a new array and give the size of the array. And then every element there is going to be like its default value. But you can reassign that whenever you need it. Okay? Let's now trace both of them. So the next line, let me use orange. How about this line here? This line here is pretty easy. So we have an array over here. Let's call it N1 for numbers 1. It's going to point to the beginning of an array of size 3. How do I know it's 3? 1, 2, and 3. Nothing else. Right? And index 0, index 1, index 2. Right? So let me be more consistent with the color. Index 0, index 1, index 2. And it should be I1, I2, and I3. I1, which is 1, should be copied over to here. I2, here, should be copied over to here. I3, oh, you can see it's also here. It's going to be copied here. Are you okay with this? If no, let me know. You need this also for reference aliasing. Are we good for this one? Not too bad, right? What about the next line? The pink one. We are creating another new array, another one. So it's going to be N2. How long should the array be? How did you know it has 3? Yeah, exactly, right? That's a convention here. So you see, inside the square bracket here, you're going to say how long numbers 1, that length is. I'm going to use the same size for creating this new array. Numbers 1, that length. Numbers 1, that length, 1, 2, 3, right? It's going to be 3. I'm just creating another new array over here. And then also indices 0, 1, and 2. And here, I don't really copy any specific value for each index. Instead, what should be the values over here? 0, default values, right? So what I will have is 0, 0, 0. Default values. So you really want to see the difference between these 2 array notation. I'm pretty sure I've seen that maybe in the first year. If no, you got to learn it now. Yes? Say that again?
What's the function of the new part on the type before the 2?
So you can think about we're basically creating an array objects over here. We are saying that we declare this numbers 2 as an array of type integer. One way to initialize it is to say, now let's create a new object of array. And the length of the array is going to correspond to the length of numbers 1, which will be 1, 2, and 3, right? And then in this notation here, every element in the array is going to be just default value to begin with, okay? Well, the one before is a different notation, right? So here you're saying I'm enumerating exactly what each value should be in different index. Index 0 should be I1, which already has some value. If I1 itself has 0, of course this will be 0. It depends, right? Yeah? Good. All right, next line. Let's talk about this block over here. All right, and put a star. It is a for loop, and I'm pretty sure I have seen for loop before. The way to trace the for loop would be you have to figure out how many iterations there are for this for loop. So the question number 1, how many iterations? Anybody? How many iterations are there in this loop? Anybody from here? How about you, please? How do you know it's 3?
Because numbers dot length retrieves the value of 3, and we start at 0.
Yeah,
Then 0, 1, 2, 3, and then there's a less than sign, so then it goes up to 2.
that's perfect answer. Thank you so much. Yes. All right, let me just repeat what your classmate said, which is exactly right. All right. So you want to use the loop counter I to help you to figure out how many iterations are there. So iteration number 1 is when I is equal to 0 in the beginning. It's going to be incremented by 1 every time. So now iteration number 2 is going to start with I being incremented from 0 to 1. Iteration number 3 is going to start with I being incremented from 1 to 2. Now we got three iterations guaranteed. Are we going to have a 4th iteration? If we were, I would be from 2 incremented to 3. Agree? But now if you check this condition over here, if this is 3, what's numbers 1 dot length? Also 3. 3 less than 3 is false. So you don't really get to the 4th iteration. Right? If you have trouble understanding this, you may want to review the basic syntax for a for loop or speak to me. Any question about this one here? I'm just trying to help you figure out how many iterations there will be for this for loop. And then we're going to go into each iteration and do the code change accordingly. That's how we trace the code. You got to trace iteration by iteration. In some way, you're just acting like a Java debugger, right? Which is important skill for you to have. You should know inside out exactly what's happening. All right, iteration number 1. For every iteration, we're going to execute this line of code. Every iteration. And of course, for every iteration, the only change we have to make is about the value for I, which could be either 0 or 1 or 2. All right, for iteration number 1, we're going to get numbers 2 at index 0 is assigned to numbers 1 at index 0. Do you guys agree? I'm basically taking this general line here. I just replace the I here by the current loop counter value 0. The next iteration, I'm going to replace the I here by 1 and then by 2. Let's do one step at a time. So for iteration number 1, what's going to happen if I have this? I'm basically saying whatever that is stored in N1, whatever that is stored in N1 at index 0, N1 at index 0, I'm going to use it and copy that over into N0 at index 0. Sorry, N2 at index 0. N2 at index 0 currently is 0. I'm going to replace it by just 1. That's what I'm doing for first iteration. What about second iteration? The same pattern over here, but I'm going to say N2 at I is now 1. Index 1 is assigned to N1 at index 1. So now I'm looking at this line here. All right? And for that one there, let's see. N2 at index 1. N2 at index 1. should be replaced by n1 at index 1. n1 at index 1 is 2, so now it should be replaced by 2. Right? Pretty clear, right? So third one, I'm just going to write it down and I'll show you. So it's n2 at index 2, corresponding to 2 here, is assigned to n1 at index 2. That one there, copy this, replace it here. That's it. Yeah, so if you kind of more or less get it, that's a good sign. Then hopefully that will help you understand when we have reference aliasing into play. Now we don't have it just yet. We're going to use a very similar loop structure later, so hopefully that one will not be a challenge for you anymore. Some question there? Yes, go ahead. The question was, why can we not initialize numbers 2 over here in the same way as we did for this one? That's your question, right? Yes. The answer is I want to show you more variety of doing the array. If you want to, you can do that as well. So alternatively, I can just follow your advice. Let me box this line. It's an interesting question here, just for everybody's benefit. Alternatively, you could have said integer numbers 2 would be, and now, right? Basically, what you want to say is index is also going to be of size 3. Index 0, index 1, index 2, right? So what you can put over here would be numbers 1 at index 0, numbers 1 at index 1, also numbers 1 at index 2. You can do that, absolutely. That will be effectively the same as a loop, but you just need to know both ways. Okay? Convinced? Yes, question?
If you put numbers 1 before numbers 2, what would happen?
I know you were going to ask. Thank you for that. I was hoping that somebody was going to ask. You guys were asking this question earlier than the morning class, which I'm happy about. Thank you. Okay? The question was, what's going to happen if we try to do, I'm going to sketch a little bit and I'll tell you. Okay? Let's say here, rather than this, I say numbers 2 is assigned to numbers 1. What's going to happen? Okay? To really do that, I will suggest I start with a cleaner page, which you deserve. And I can make it even better. Can I just crop? Sorry. If I cannot, okay, never mind. I used to be able to do that more easily, but let's now do this. Okay, now I want you to consider this. This line here, oh, you know what? Let me tell you the change. Rather than this, what about here? I just say, put on the right-hand side, numbers 1. For the rest, just disregard for now. Okay, I just want you to focus on just that line there. Just focus on this line. All right? Anybody want to make a suggestion before I visualize it for you? Once I visualize it, it's not too bad. What you want to think about is this for your answer. When I say numbers 2 is assigned to numbers 1, are they primitive types? Not really. If they're reference type, we are really just copying address. What address are we copying? Are we copying address of a person? Or are we copying address of a point? Or are we copying an address of an array? Array, right? Let's now take a look. So now this one here is basically saying this. Copying the starting address of numbers 1 to numbers 2. All right, let's now take a look. I know that after this line here, Numbers 1 is pointing to an array of size 3, as we explained before. 0, 1, and 2, right? 1, 2, and 3. And by executing this line, we are basically saying, don't create a new array anymore. Instead, N2, being an array address, is now going to store the starting address of what M1 is storing. Diagrammatically, pointing to here. That means N1 and N2, they're pointing to the same array. Does that make sense to you? This one here? Okay. And of course, you can try different things over here. You can try, for example, after this, if I try N1 equals N2. True or false? True, right? Obvious. And there's something about aliasing over here. Okay? If I say N1 at index 1 is assigned to 46. Now I'm asking something else. N2 at index 1 equals 2. All right? That would be a nice exercise for you. Should this be true or false? I was trying to modify N1, but why is N2 also impacted to be something that's not 2 anymore? Why? What's the reason? Anybody? Yes, because they have the same starting address, they're pointing to the same object, exactly. All right, so here you can think about when we execute this line over here, N1 at index 1 modified to be 46. So you can see similar idea. Because N1 and N2, they're pointing to the same array objects, so modifying this slot over here is also visible to M2. All right? So that's why you're going to get false over here. It's not 2 anymore. It's now become 46. Right? And this could be useful for a little bit later, once we get to tracing the array example. Okay? Yeah, this is actually very useful because that's something I'm really meant to mention a little bit later anyway, but I can revisit once we get there. All right, let's now go back here. What I want to do is complete an example. So if I try to execute this line, numbers 1 at index 0 is equal to 4. So numbers 1 at index 0 is equal to 4. So it's now going to be 4. All right, let's answer some question. Numbers 1 at index 0 should be 4. And numbers 2 at index 0 should be 1. Right? Well, the point is you can see 4 here versus the 1 here. They are not impacting each other. There's no aliasing. Right? But I would say this particular example here involving only primitive array, the main thing is for you to remind yourself how to trace loops, which will be useful. Okay? That's one lesson I would like to review. Any question about this? Yes?
The column is have to be greater than 0. So why is when the index of the number 2 0 is still like have the value for it is double 96?
Sorry, I don't quite get you. Are you more referring to the loop over here? Sorry, let me just try to follow you. You're talking about this loop over here?
Yeah.
What about it? Sorry, say it again.
You have a condition for it, right? So it has to be greater than 0. The number 1 length has to be.
It doesn't need to be over here, but it's a slight side issue. So here, this loop is going to work regardless of the length of the two arrays, because the way we create a second array is going to have the same length of the first array. Let's imagine, I'll sketch that a little bit, you can think. What if, so here I just put empty array. Okay? If there's empty array, numbers 1, the length will be just 0. So both numbers 1 and numbers 2 will be empty array. Okay? And now, if both of them are empty, what's going to happen to the for loop over here? I initially will be 0, less than numbers 1 the length would be 0. 0 less than 0 is going to be false. So we don't even get to the first iteration. So nothing to copy because they're both empties. Make sense to you? Yeah, good. It's a different tracing problem, right? So of course I can set up the length in a different way. That can also have different consequences for sure. All right, any more question about this before we move on to something similar, but we're going to add reference type into play. All right. Let's now do it. And for those of you who got a piece of paper, blank paper, or you got your iPad, so please have a blank page ready. I would like you to do that together. Let's go block by block together. Yeah, get yourself ready. You know, I think it's really worth doing this. We got about 20 minutes. We'll see what we can do, right? But I'm really hoping to at least finish this example today. Let's do it together. Yeah, get a piece of paper if you have, or you can open up a blank page on your iPad, your tablet, and let's do the tracing together. This will be the best chance for you to exercise. All right, ready? Okay, your task number 1. Let's go block by block. Not to really ask you to trace everything in one go. That's too much. All right, so now can you please visualize what's happening after executing from line number 1 to line number 4? And let's make the following assumption. In the person class, we got only 2 attributes, the name and the age. Integer age and the string name. Let's make the following assumption. Okay? And now, how would you visualize the runtime structure after executing line number 1 to line number 4 inclusively? I'm going to draw on my iPad a little bit, but you should really take a minute or 2 to draw it. That should be the simplest part. And funny enough, this might be the part that requires the most drawing. Okay? But anyway, give it a try. I'll give you 1 minute, please. Okay, maybe another 30 seconds, right? You shouldn't take long. This should be the easier part. Can I just have a simple check with you? How many boxes are you going to draw? 4. Because you got 4 new keywords. 1, 2, 3, and 4. Easy check, right? Okay, I'll give you 10 more seconds, but if you haven't done yet, you can just catch up, while I reveal my answer. All right, let's take a look. So we got 4 boxes over here. That would be something you will see, all right? I cheated a little bit. I pre-drew the box before, but you should really try to draw from scratch when you trace the code, all right? So after these 4 lines, 1, 2, 3, and 4, you can see that we got Alan pointing to an object, Alan. What about age? So we are assuming that this constructor over here is going to leave the age value default, which is 0. Let's assume, okay? And the second one, we got Mark pointing to Mark, age also 0. We got the third object, Tom, pointing to a new object here. Name will be Tom. Age will be 0, default. Finally, we got Jim pointing to this new object here. Name will be Jim, and the age will be 0, default. Right? Easy. And Now you will see something very, very similar to what we did. This line here, let me bring back your memory. This one here, very similar to this one here. Agree? Basically structurally the same, except this will be person. And I1, I2, I3 are just replaced by person variables. That's the only difference, right? That's why I want you to compare. Now, how do we visualize this line, right? That's the question. I would suggest the following. You want to think about the way Java execute this line behind the scene is to break it down into 4 lines. All right, I'll show to you. Let me use this. Okay, I'll put a star here. Okay, I'll put star here. 4 lines. Line number 1. We're basically declaring this person array, persons 1, I'll say P1. And we know that it's going to be 1, 2, and 3, size 3. So that'll be new person. The length should be 3. So this 3 here is not really magical because I want to give 1, 2, and 3. So that's why the length should be 3, just enough. All right? That'll be line number 1. Line number 2, I want to assign Alan, Mark, and Tom accordingly to the corresponding index in the array. So you can think about this will be index 0, index 1, index 2. All right? So the next line will be something like this. It will be persons 1 at index 0 should be assigned to Alan. Persons 1 at index 1 is assigned to Mark. Persons 1 at index 2 is assigned to Tom. So think about this line over here can be understood as these 4 lines over here. And we're going to see what it will do. I'm just going to make some little bit more space for myself. Okay, let's now do line number 1. This one here is easy. You basically say P1 should be pointing to an array of size 3. In the beginning, every slot in the array, so index 0, index 1, index 2, in the beginning, every one of them is going to point to null, right? Default value for reference type, remember? Let me say N for short. Null, null, and null in the beginning. Let's be very precise about the detail. Now, I need your input. How do we understand this line here? P1 at index 0 is assigned to Alan. What are we doing here? I'll get to you. Anybody from that side? Anybody who hasn't spoken yet today? Feel free to speak up. How about, sorry, you, how about you? Please go ahead.
So the first part, it's placing on item number 0, the address of the object
Yeah, you definitely want to copy the, okay, let me be a little bit more precise so your classmate can also follow. Let me ask you this so we can lead everybody. Are we trying to copy this into this? Or are we copying this into this? Which one? Are we copying Alan into this? Or are we copying this into Alan? The first one, good. We are assigning this value here into this, right? And we know that this one here is really the address of the Alan object over here. We're copying the address of this object here into P1, 0. So P1, 0, which will be this slot over here, is going to store the same address as this object here. Diagrammatically, how should we update? Well, P1, 0 should point to the same object as Alan pointing to. Guys, are we okay with this? Okay. Let me say it again. We here copy the address stored in Allen to index 0 of P1. That's what we're doing. All right, so diagrammatically, we're basically saying the address here is going to be copied over to here. So now P1 at 0, rather than pointing to null, is now going to point to here. All right? And if you go to the next line, how about this? That one is the P1 at index 1, which is this slot over here, is now going to point to wherever mark is pointing to, which will be here. Right? Rather than pointing to null, it's now going to point to wherever mark is pointing to. Finally, what about this line over here? Right? This line here, wherever P1, wherever Tom is pointing to, which will be this object here, let P12 point to the same spot, the same objects. So P12 is referring to this slot over here. So rather than pointing to null, it's now going to point to the Tom object over here. Are we okay with this? All right. Think about it. I'll be in the lab session tomorrow. Maybe try to redo the exercise and then ask me a question tomorrow. That might be the best way to do it, right? Let me continue. How do we now trace the following two lines? Sorry, the following here. 1, 2, and 3. Now it should also look very familiar, right? The loop, we already did it. Right? We already understand how to trace this loop. 3 iterations. But now, the way we copy things over here will be to copy address, but not integers anymore. But it's not too bad. All right, let me dive into it. Here, this part, right? Star, star. What's going to happen is, first of all, we got persons2 array is going to have the same length as persons1.length. We know that how long is it? 1, 2, and 3, right? So P2 is going to be an array over here of size, over here, 3. So I'm going to get 0, 1, and 2. In the beginning, just point to null. It's only this line I have traced, only this line, creating just this array. And then I'm going to dive into the 3 iterations of the loop and see how things are going to go. Right? But if you have understood so far, it should be no trouble for you. But let's do it together. So we're going to have iteration 1 and 2 and 3. Iteration number 1, iteration number 2, and also iteration number 3. All right? Oh, let me just annotate for you about what I value should be. It's critical. In the beginning, I will be 0. Second iteration, I will be 1, right? This one I can assume you know because we explained that already. And then I equals 2, right? Let's now talk about the first iteration very carefully. The subsequent 2 iterations will be very similar. So what would the first iteration boil down into? Basically, we're going to apply this pattern here, but I here is going to be the current I value, which would be 0. So we're going to get persons2 at index 0 is assigned to persons1, right, at index 0. Make sure we understand this one properly. The subsequent one should be fine. Now, how do we understand this line here? Again, we're copying the address, right? What we are copying here is, we are copying whatever that is stored in P1 0, which is over here, the address of this particular object. We're copying the address of this object here into P2 0. P2, 0 is currently pointing to null. After this copy here, P2 at index 0 should no longer point to null. It should point to this here. Agree? Okay. So what's going to happen is after this, P2 at index 0 is now, rather than pointing to null, is going to point to wherever P1, 0 is pointing to. Let me highlight it. P1 at index 0 is pointing to this object here. And now P2 at index 0 is also pointing to the same objects. That's what we're doing for the first iteration. Are we okay for the first iteration? Well, second and third will be similar. I'll write them out and then I'll draw that. And then we should be able to do a little bit more updates. Okay. The second iteration, P2 at index 1, because now we talk about 1. And also P1 at index 1. So what should I do? So P1 at index 1 is referring to this object here. So P2 at index 1 should now point to that particular object, right? Rather than pointing to null, it's now going to point to that object here. That's what we end up with. Second iteration. Okay? Third iteration for completeness. Let's say P2 at index 2 is assigned to P1 at index 2, right? P1 at index 2 is pointing to this object here. P2 at index 2 is currently storing now, but we want to make sure it points to the same object after the assignment. After this, it's going to point to here. All right? That's what you will get. 3 iterations, right? And let's now move on. We should have it about 3 minutes. Let's see how much we can do. So here, let's see this. Person 0 set age to be 70. Okay, what does that mean? So let's now trace this line. Persons 1, 0. Persons 1, 0 is pointing to this object here. Right? You want to set its age to be 70. So I'm changing this one to be 70. That's what I'm doing. And after that, what will be Jim.getAge? Jim.getAge should be 0. No change. Alan.getAge, 70, right? Yeah, you can see just go. Here's the deal. If you have drawn your diagram correctly, there's no way you can get the answer wrong. Because reading the diagram is so straightforward. But the assumption is big. You have to know how to draw diagram. Right? All right, how about this? Persons 2, 0, get.getAge. Right? Person 2, index 0.getAge, right? You will be 70. Thank you. All right. Can you just give me 2 minutes and then I can get this done? How about here? Persons 1 at index 0 is assigned to Jim. So what we're doing is persons 1 at index 0 over here, rather than pointing to over here, is now going to point to wherever Jim is pointing to. So we are basically doing this. So it's now going to point to this. Sorry. What might be the best way to draw this? Okay. So here it's going to point to this object here. You can definitely do better on your paper. All right? It's pointing there. And persons 1 at index 0, persons 1 at index 0 is now pointing to this object here, right? Let me follow that link. It's really pointing to this object over here. Set the age to be 75. So Jim is of age 75. Okay, give me 1 more minute. I can get it done. Jim.getAge, 75. Alan.getAge. Alan is still pointing to this object here. It will be 70. How about the last one? Persons 2 at index 0.getAge. 75, all right. Persons 2 over here at index 0 is pointing to here. It's still 70 actually, right?
But isn't it holding the address of,
No, it's persons 2, not persons 1. Right? So let me say it again here. Persons 2 is over here at index 0 is pointing to still this object here, so that will still be 70. But if somehow you're referring to this object here instead, it will be 75. Depends. All right? So I think what you should do, try to redo this example here. It's already on the study site. And then if you got any trouble tracing it, let me know. And then we'll continue from here next on Thursday. Yeah, come here. See you later.
I have a quick question. So,
Now, give me one more. Let me stop the recording first.